So how's everybody doing out there? Well, welcome to day 12 of Corona Online School. So today we're actually covering the last unit of the semester. Woohoo, you guys have made it. Good job. So what we're going to talk about today is symmetries and tilings. So if you haven't already gone and looked at the definition slide, you might want to go look at that before we actually go into the actual video here. So pause this at this point because there's a lot of definitions in this section. So you can see all the different blank spots to write those down. So once we come back, so the first thing we're going to talk about is like the line symmetry. And so again, this is like our reflection that we had talked about before. So what you want to do is think about mirror lines that you could draw to do these reflections. So for example, like this heart, you could cut it right down the middle. And if we fold our picture across that line, that would give us our nice reflection symmetry. So in this section, there could be more than one. So with the heart, there's obviously just one. But like if we look at the square, for example, like the square, we could cut it this way. We could cut it this way. We could cut it this way. And we could cut it this way. So the square actually has, what, 4 lines of symmetry. So kind of keep that in mind when you're working through these. So there's a bunch of those for you guys to practice. So I'll let you work on those. So rotational symmetry is just like our rotation translation. And so the main thing to remember with rotational symmetry is that eventually the figure will turn back on itself again. And so with these, if you rotate them some degrees, they'll end up, being exactly the same figure over again. So again, make sure you read these definitions and stuff. There's a lot of definitions with gaps in here. So I'll let you guys try part 2. So again, this is kind of some fun ones, drawing some polygons that have certain figures, things like that. And so tiling is what you guys actually did with your tessellations. So it's basically taking some kind of a plane and trying to cover that plane with certain figures. So if you think about like a tile in a kitchen floor or something like that, that would be a good example. So the one thing I want you to think about is number 7. So we don't have the pattern blocks to actually try this out, unfortunately, but it's saying which 3 regular polygons could be used to form a regular tiling. So if you haven't seen the definition, you don't know what regular tiling means, but basically means you have to use regular polygons in your tiling. And so the hint for this one is think platonic solids. So remember, there were only certain regular polygons that you could use to actually form platonic solids. And it turns out the same reason it's true for platonic solids is going to be the same reason it's true for tilings, which is kind of a nice little connection. And so vertex figure is a cool thing. So again, it allows you to take a lot of different shapes and put them together, and you're trying to see how many shapes you can actually get at one point. So again, if you think about our platonic solids, that's what we actually did. We tried to see how many triangles could we get at a single point, how many squares, how many pentagons, and things like that. Now the nice thing about a vertex figure is you're allowed to use different shapes, but the big key to vertex figures is all the angles need to add up to 360, which you'll see in the slide too, so don't worry about it. And so here's some questions about vertex figures. So I want you to try those, guys. And then last couple here is just like actually trying to tile the plane using certain figures. So if you have any questions or anything, let me know. I'll be around the computer all day tomorrow. So otherwise, good luck.